The engineering behind Chinese New Year is genuinely insane. We are talking about the largest single celebration on the face of the earth. 9.5 billion trips, entire cities lighting up at the same time. 16,000 drones painting the sky from a single computer. A power grid holding together under pressure that would destroy any other nation's infrastructure. And here is what that actually means in numbers. During the 15 days of Chinese New Year, China burns through more electricity than the entire United Kingdom consumes in a full year. You heard that right. 15 days. One full year. And almost nobody outside of China has any idea how much engineering it actually takes to make this happen. But before we get into any of that, you need to understand the scale of what is actually happening on the ground. Every year, hundreds of millions of people in China need to get home at the same time, for the same holiday, and the window to do it is razor thin. This migration has a name. It is called Chunyun, and it is the single largest coordinated human movement on the face of the earth. 9.5 billion trips, 40 days, 20 or more government departments working in lockstep to make sure it does not fall apart. Before a single train leaves the station, China has already been planning this for months. The railway sector alone runs over 14,000 passenger trains on peak days. 540 million people ride the rails, 95 million fly, and 80% of the 9.5 billion trips are made by car. You heard that right, 80%. Now here is what makes this so terrifying from an engineering standpoint. The flow is not steady. It is not spread out evenly across 40 days. It is a massive, uneven surge. Before the holiday, the coastal megacities empty out. Hundreds of millions of workers flood back to rural towns and villages across the country. The direction of travel flips completely. And then, after the holiday, it reverses again. Every single person has to come back. The entire thing has to be orchestrated twice, in opposite directions, without collapse. And the railway system bears the brunt of it. In 1978, China had roughly 32,000 miles of rail track and 0 high-speed lines. Today, the network has expanded to over 100,000 miles. 30,000 of those miles are high-speed rail, the largest high-speed network on the planet. That expansion is the single biggest reason Chunyun has not broken the country. High-speed trains absorb the surge that the old system could never handle. But even with that network, on the busiest days, 14,000 trains are running simultaneously across the country. The scheduling alone is staggering. China's Rail Control Center in Beijing monitors almost every single train in the country in real time. Speed, route, position, all of it, live on a single screen. Facial recognition has replaced ticket inspectors at major stations passengers walk through in 2 to 10 seconds. No queues, no paper tickets. AI-powered routing systems dynamically reallocate capacity based on passenger flow data. Carpooling apps coordinate last-mile travel using algorithms that sync with train schedules in real time. But here is the thing that keeps the engineers up at night. One bad snowstorm, one system failure, one cascading delay at a single hub station, and the entire migration grinds to a halt. In 2008, a brutal winter storm hit during Chunyun and stranded over 100,000 people at a single railway station in Guangzhou. Over 1 million troops and reservists had to be deployed just to clear the roads. The whole country watched it happen, and it has never been allowed to happen again. But moving 9.5 billion people is only half the problem, because once they all arrive, every city in China lights up at once. The moment Chinese New Year hits, the power grid takes a hit like nothing else in the world. Every city, every village, every household, heating, cooking, lighting, celebrations, all of it slams into the national grid simultaneously. And China's grid is already the largest and most stressed power system on the planet. China produces more electricity than the United States and the entire European Union combined. The national power supply reliability sits at 99.924%. That sounds impressive, and it is. But 99.924% on a grid that serves 1.5 billion people still means thousands of moments per year where something goes wrong somewhere. During Chinese New Year, the margin for error shrinks to almost nothing. So how do they keep it from collapsing? The answer starts with ultra-high voltage transmission. Here is the problem nobody outside of China fully appreciates. The best solar farms, the biggest wind installations, the most powerful hydroelectric dams, almost all of them are in the remote western provinces. Thousands of miles away from where the people actually live. Thousands of miles away from where the power is actually needed. So China built the most advanced ultra-high voltage transmission lines in the world, capable of moving electricity across that entire distance with almost no loss. These lines carry electricity at voltage levels that most countries have never even attempted. They are the invisible arteries that keep every city lit up when the entire nation demands power at the same time. But transmission is only one piece of the puzzle. When the surge hits, the grid needs to respond in fractions of a second. And China has developed technology that can isolate a grid fault and restore power within 1/10 of a second. 1/10. A team of researchers spent over a decade building that single capability. Scientists from universities, power equipment manufacturers, the national grid operator, and automation companies, all working together for 10 years to shave the recovery time down to 100 milliseconds. Because in a grid this massive, a failure that lasts even a few seconds does not just inconvenience people. It cascades, it spreads, it can take down an entire region. The kind of blackout that shut down Spain and Portugal for 18 hours in 2025 and brought their entire country to a standstill, that is exactly what China is engineering its way out of. And then there is the battery. China is now the largest market in the world for grid-scale lithium-ion batteries. Companies like CATL supply the storage systems that perform what engineers call peak shaving, absorbing the surge of demand when it hits and releasing that stored power back into the grid when it is needed most. Battery systems in China are now reaching prices of $60 to $70 per kilowatt hour. And that changes everything, because suddenly, power does not have to flow from one fixed point to another. It can be stored, it can be moved, it can be released on demand. Without this, the simultaneous celebration of over 1 billion people would tear the electrical system apart. But keeping the lights on is one thing. What happens when those lights turn into an explosion of fire in the sky that is an entirely different engineering nightmare? Before a single firework launches over a Chinese city on New Year's Eve, it had to be built. And almost all of them come from one place, a city called Luoyang in Hunan province. And what is happening inside Luoyang is something most people have never seen or even heard of. Luoyang is not just a fireworks producer. It is the fireworks capital of the entire world. 431 factories, all packed into one city, producing enough pyrotechnics to supply not just China, but the planet. Almost 70% of China's fireworks exports come out of Luoyang. The city produces over 60% of the world's fireworks and firecrackers. One city. 60% of everything that lights up every sky on every celebration across the globe. And the production process inside those factories is brutal. Every single firework goes through 12 steps and 72 individual procedures. The chemicals have to be measured to the ounce. The shells have to be packed with precision. One miscalculation, and the firework does not just fail, it kills someone. So the industry has been forced to automate. One factory invested 110 million yuan, roughly $15 million, into building a fully automated production line. The entire line runs with just 50 pounds of gunpowder, spread across 18 separate machines. No human touches the explosives. The workers are isolated from the product entirely. One company went from 300 workers handling gunpowder to just 11. 11 people running a line that produces 2 million boxes of fireworks a year. The machines do everything: mixing, loading, sealing, testing, all of it, without a single human hand near the chemicals. But building the fireworks is only the beginning. The real challenge is getting them all to explode at exactly the right moment, across hundreds of cities, all at once. The ignition systems used during Chinese New Year are fully computerized. Every launch is programmed. Firing sequences are choreographed down to the millisecond. Multi-break shells, fireworks with multiple layers packed inside a single casing, detonate in timed intervals, creating cascading patterns in the sky that look effortless but require split-second precision to execute. Each shell has to travel to exactly the right altitude before it bursts. Too high, and the colors wash out against the sky. Too low, and it is a danger to everyone below. The engineers calculate the precise trajectory, the exact amount of lift charge, and the exact burn time of the fuse for every single shell. And this is happening across dozens of cities at the same time. Thousands of fireworks launching simultaneously across a single city, each one timed to the exact frame of the display. Pyrotechnic operators sitting at control panels, watching monitors, executing choreographed sequences that took weeks to program. One wrong signal, and the entire show falls apart. Or worse. The operators who run these shows spend years learning the craft. Some have spent over a decade sitting at the controls on New Year's Eve, reading the sky, adjusting in real time if the wind shifts or a shell misfires. It is not just engineering. It is precision under pressure. And the stakes are not abstract. A firework that detonates at the wrong altitude, at the wrong angle, over a crowd of thousands that is not a malfunction. That is a catastrophe. But here is where it gets even more insane. Some cities have started replacing fireworks entirely, and what they replace them with will blow your mind. Imagine looking up at the night sky and watching thousands of tiny lights begin to move. Not fireworks, not stars, drones, thousands of them, moving in perfect formation, painting images in the air, dragons, phoenixes, entire landscapes, all in real time, all in silence. This is drone swarm technology. And China has turned it into an art form that the rest of the world cannot touch. In Shenzhen, a single drone light show launched 15,947 drones into the sky. You heard that right. Nearly 16,000 drones, controlled by one computer. Every single drone knew its exact position in the sky down to the inch, tracked by RTK positioning systems, and connected to every other drone through mesh networking. One computer, 16,000 robots. One flawless show. The choreography behind it is staggering. AI pre-programs every single flight path and altitude before the show even begins. Each drone carries an LED array capable of displaying up to 256 colors. They move in three-dimensional formations, shifting and reforming mid-air to create images that shift every few seconds. Pagodas, dragons, entire cityscapes. All built out of light, hovering hundreds of feet above the crowd. And then some of those drones carried actual fireworks. 7,496 of the drones in that Shenzhen show had live pyrotechnics attached. Silent drone ballet 1 second, fireworks exploding the next. Two technologies, centuries apart, fused into a single show. Chongqing took it even further. Their New Year's celebration combined drones, laser projections, water curtains sprayed from performance vessels sailing along the river, and building-scale lighting networks, all synced together into what they called a water-land-air integrated performance. The entire skyline became part of the show. But here is what terrifies the engineers behind this technology. It has already gone wrong. At a previous show in Luoyang, a malfunction sent burning drones falling toward the crowd below. The same technology that paints dragons in the sky can, if it fails, drop fire onto thousands of people. And the margin for error with 16,000 flying machines is almost non-existent. But the drones and the fireworks are just the spectacle. Behind all of it, there is an invisible problem that almost nobody is talking about. And it is one of the most quietly terrifying challenges of the entire celebration. 44 million electric and hybrid vehicles are on the roads of China. And during Chunyun, a massive portion of them are moving at the same time. All of them need power. And the charging infrastructure has to keep up with something it was never designed to handle at this scale. Along the freeways of China, there are over 71,000 EV charging connectors at service areas. 71,000. And on the surface, that sounds like enough. But during the Spring Festival travel rush, demand does not scale linearly. It spikes. Entire stretches of highway see hundreds of vehicles pulling into the same service areas at the same time, all needing a charge before they can keep driving. Some areas see queues forming before dawn. Families sitting in parking lots, watching the clock, knowing they still have hundreds of miles to cover and the battery is already at 15%. So China has deployed mobile charging units that can be dispatched to congestion hotspots in real time. Real-time availability data is pushed to drivers before they even reach a service area, so they can reroute if a station is already full. Smart service areas have been engineered from the ground up, integrating charging, food, and logistics into a single hub designed specifically to absorb the kind of surge that only happens once a year. But the deeper problem is this. If the charging infrastructure fails at scale during Chunyun, it does not just mean some people are delayed. It means hundreds of thousands of vehicles are stranded on highways across the country, families trying to get home, workers who have not seen their children in a year, and there is no backup. No engine to fall back on, just an empty battery and a road that still has miles to go. The pressure on this system is only going to grow, because every year, more people drive electric. And every year, Chunyun gets bigger. And all of this, the trains, the power grid, the fireworks, the drones, the charging stations, none of it is running on instinct. None of it is being managed by humans alone. There is something else holding the whole system together. And it has been watching all of it from the moment it starts. Every single system we have talked about, the transit coordination, the power grid management, the fireworks timing, the drone swarms, the EV charging logistics, all of it is being monitored, optimized, and adjusted by artificial intelligence in real time, simultaneously. And most people watching these celebrations have no idea it is even there. AI is the invisible brain behind Chunyun. It is predicting passenger flow before the rush even begins, using historical data, weather forecasts, and real-time movement data to dynamically reallocate train capacity, reroute flights, and adjust highway traffic signals across the entire country. It is not reacting to problems, it is anticipating them. Hours before a congestion point forms, the system has already shifted capacity somewhere else. It is managing the power grid, predicting demand spikes before they hit, and triggering battery storage systems to absorb the load before it reaches the infrastructure. It is syncing the fireworks launches across dozens of cities so that every single shell detonates at the exact millisecond it is supposed to. It is coordinating the drone swarms in the sky, 16,000 machines, moving in perfect formation, all governed by algorithms that adjust flight paths in real time based on wind, battery life, and signal strength. And it is pushing charging availability data to millions of drivers on the road, rerouting them before they even know there is a problem. Entire cities have been redesigned around this. Smart city systems use sensors embedded in the roads, in the buildings, in the transit hubs, feeding data back to central AI systems that make thousands of micro-decisions every second. Real-time crowding alerts tell drivers which expressways are congested before they get there. Dynamic seat allocation apps on high-speed trains fill every available seat with zero waste. The government has even started piloting smart road service areas that integrate everything EV charging, food, parcel pickup into a single AI-managed hub, stress-tested specifically during the Spring Festival rush. This is not the future. This is happening right now, every year, without fail, and it is the reason the whole thing works. And when the celebration is finally winding down, when the fireworks have faded and the migration has reversed, there is one final act, one last spectacle that closes the entire thing out. And the engineering behind it is just as wild as everything that came before. 15 days after Chinese New Year, the Lantern Festival arrives. And this is where tradition and futuristic technology collide so completely that it is almost hard to believe it is real. In Zhejiang, a single lantern installation stretches 690 feet long and rises 105 feet into the air. Over 400 artisans worked on the lanterns for that single festival. One lantern set covers more than 135,000 square feet, roughly the volume of a 30-story building, built out of light and steel and silk. And every single piece of it had to be engineered to survive outdoors, to hold its shape under wind and rain, and to carry tens of thousands of LED lights without a single failure. A single horsehead lantern takes 4 people 4 full days to complete. Over 300,000 feet of custom fabric wrapped, glued, and detailed by hand across the entire installation. But the lanterns are not just hanging there passively anymore. Cities like Shanghai have built 3-story revolving lanterns using traditional mortise and tenon joinery fused with digital projection systems. The panels rotate continuously, animated by light, telling stories that shift every few seconds. In Shenzhen and Guangzhou, lantern festivals now feature holographic projections, fog systems that create immersive environments where reality and illusion blur together, and sensor-based installations where your movement triggers changes in light and color around you. Some installations use animated eyes and dynamic sound effects to make the lanterns feel genuinely alive. Others use AI-powered smartphone features to give visitors virtual guides, interactive riddles, and full VR experiences layered on top of the physical display. The Forbidden City in Beijing, one of the most ancient and sacred sites in the country, has been lit up with LED arrays and projection mapping that animate its walls with stories from thousands of years of history. Ancient architecture turned into a screen, and it works. And here is the number that captures just how massive this has become. Searches for drone light shows during the Lantern Festival surged 318% in a single year. Searches for holographic projection experiences surged 11-fold. The entire nation is not just watching these shows. It is demanding more, bigger, brighter, more technologically impossible than the last. So this is the full picture. 9.5 billion trips coordinated across 40 days. A power grid serving over 1 billion people kept stable through AI and ultra-high voltage transmission and batteries that respond in fractions of a second. 431 factories in a single city, producing 60% of the world's fireworks through fully automated production lines where no human hand touches the explosives. Nearly 16,000 drones painting the sky from a single computer. 44 million electric vehicles kept charged across an entire national migration. Artificial intelligence, orchestrating every single piece of it simultaneously. And then, 15 days later, lantern installations, the size of skyscrapers, built by hand, animated by holograms, powered by sensors that respond to your body closing out the longest, most engineered celebration on the face of the earth. This is not just a holiday. This is the most complex engineering operation a single nation runs every single year. And almost nobody outside of China has any idea just how insane it actually is.